In this video, I'm going to take you through the first part of the 6.2c lesson. Number 1, on the coordinate plane below, find the distance between points A and C and the distance between points C and B. So between A and C, 1, 2, 3 units. And between C and B is 7 units. And then make an estimate for the distance between A and B. Hopefully you can see that there's an issue to find the exact length of this because we can't count along the grid. Based on the fact that, and number 2 asks us to do this, that we could build a right triangle, we should know that AB must be longer than 7 units. So for C, you could try to make an estimate, but we're going to now skip to what's the precise way to figure out the length of AB. So if this is 3 and this is 7 and I want to find AB, I could use Pythagorean theorem and label this C. There's my right angle. So using Pythagorean theorem, I'm going to have 3 squared plus 7 squared equal to C squared, which is 9 plus 49 equals C squared, which is 58 equals C squared. Which means that C equals the square root of 58 units. And 58 is divisible by 2, but beyond that, that would be 2 times 29. That's going to be actually fully simplified as it is. There won't be any pairs in there. And we can see that this is bigger than 7, but less than 8. So we made an estimate, although I didn't write it down, that it would be bigger than 7. Then we get down to an all variable situation where we have a point B at x sub 1, y sub 1, x sub 2, y sub 2. We want to find the distances between A and B. And the first thing that it asks us in A to do is to find the coordinates of C. And also keep in mind that we used some of these same ordered pairs when we figured out the slope formula, but here we're figuring out what the distance is. So C is at the same height as B. So that would mean that C has y sub 1 as its y component because it's the same height. C also has the same horizontal position as A, which means that this would be x sub 2. So it's to the right x sub 2 units, just like A is. Let's draw in the triangle. So it seems like this lesson is building on the lessons from Pythagorean theorem. So to find the distance in AC when we had a vertical segment, like in example number 1, we found the difference between the y's. Kind of like we do for slope. It's actually the same slope triangle. And then to find the horizontal, we're going to find the difference in the x's. So AC, its length would be y2 minus y1. And for BC, it would be x2 minus x1. And then using Pythagorean theorem, we're going to figure out what AB is. So BC squared, which means the distance of BC, plus AC squared equals AB squared. And we'll plug in what we know. So we know that BC is x sub 2 minus x sub 1 squared plus AC is y2 minus y1 squared, and AB squared is as it is. My goal is to get that. And so to isolate it, I will square root both sides. And I'm going to flip-flop my equation just so that it's organized. For my final answer would be that AB is the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. And so I actually just derived, using Pythagorean theorem, what we call the distance formula. This will give us the distance between any 2 points on the coordinate plane. Specifically if the points are not vertical or horizontal, because if they're vertical or horizontal, it's really easy. Next page, there's the formula. And you're probably asking yourself, does order matter in some of this? Because we talked previously with the slope formula that we could maybe do some changing in how we arrange things and it still worked out. And so we'll kind of ask the same thing as we're going through these, if order will matter, or how we could potentially move things around and still get the same answer. So as I'm doing these, though, the first thing I'll do is I'll label my points for these first few examples, and I'll label them in the order that they're stated, and then maybe I'll start to consider what will happen if I put them in a different order. So I have 6 minus 3 squared plus 9 minus 5 squared. And there's been some examples in the module that has shown that we cannot cancel the square root and the squaring because we first have to add these. That it's almost like there's another set of parentheses or brackets around these parentheses that we need to do this first. So this would be 3 squared plus 4 squared, which is 9 plus 16, which is the square root of 25, which is 5. Oh, cool. This is actually our 3, 4, 5 triangle, in fact. So the distance between these 2 points is 5 units. Number 5, x sub 1, y sub 1, x sub 2, y sub 2. So RS, 3 minus negative 1 squared plus 8 minus 4 squared. Every line of work I'm copying down this square root, even though it's kind of annoying. 4 squared plus 4 squared. 16 plus 16. I'm waiting to square root until the very end. 32. 16 times 2. So this will be 4 root 2. Every time I have to simplify if it does not come out to be a rational number. Number 6. So 2 minus 0, negative 3 minus 5. It's 2 squared plus negative 8 squared. Just 4 plus 64. I should not have a negative under my radical at this point. It should go away, which is the square root of 68. And there's a 4 in there. 4 times 17, I think. Just 2 root 17. And now you might be ready to ask yourself, can I change the order of my points? Will that change the distance? So on this one, I'm going to label my first point x2, y2, x1, y1. And you can feel free to try it the other way and see if we get the same thing. I have a feeling that you know the answer to this, because think about the picture on the previous page. Would it matter which point I start with when I'm measuring distance, A or B? Okay, so negative 3 minus 2, and you could be trying this the other way, and negative 5 minus negative 7, which is negative 5 squared plus 2 squared. 25 plus 4, root 29. And so if you tried labeling your points the other way, we should have still gotten the same answer. In fact, it doesn't matter how you label your points as long as x2, y2 go together. So this was the intro to this lesson. We'll finish this lesson in the coming days, but by Monday, 0 period, please finish 1 through 7, which we just did in the video. Also, feel free to check the lesson key that's on Blackboard.